Saturated carbon in all its allotropic forms burns in oxygen to form carbon dioxide along with the release of heat and light. Most carbon compounds also release a large amount of heat and light on burning. These are oxidation reactions. C plus O2 gives CO2, CH4 plus O2 gives CO2, CH3 ethanol, CH3 CH2OH plus O2 gives CO2 plus COH2O plus heat and light. Saturated hydrocarbons will generally give a clean flame, while unsaturated carbon atoms give a yellow flame. Supply of air results in incomplete limiting the supply of air results in incomplete combustion of even saturated hydrocarbons, giving a sooty flame. The gas kerosene stove used at home as inlets for air, so that sufficient oxygen-rich mixture is used to burn to give a clean blue flame. If you observe the bottom cooking vessels getting blackened, it means that the air holes are blocked and fuels is getting wasted. Fuels such as coal and petroleum have some amount of nitrogen and sulfur in them. This combustion results in the formation of oxides of sulfur and nitrogen, which are major pollutants in the environment. Carbon compounds can easily be oxidized on combustion. In addition to the complete oxidation, we have reactions in which alcohols are converted to carboxylic acids. Alkaline potassium permanganate or acidified potassium dichromate uh, or oxidizing alcohols to acids, that is adding oxygen to the starting material. Hence they are known as oxidizing agents. Unsaturated hydrocarbons and hydrogen in the presence of catalysts such as palladium or nickel give saturated hydrocarbons. Catalysts are substances that cause a reaction to occur or proceed. This reaction is commonly known as hydrogenation. At a different hydrogenation of vegetable oils using a nickel catalyst. Vegetable oils generally have a long saturated carbon chains, while animal fats have saturated vegetable oils have a long unsaturated carbon chains, while animal fats have saturated carbon chains. You must have seen advertisements stating that some vegetable oils are healthy. Animal fats generally contain saturated fatty acids, which are said to be harmful for health. Oils containing unsaturated fatty acids should be chosen for cooking. Saturated hydrocarbons are fairly unreactive and are inert to the presence of most reagents. However, in the presence of sunlight, chlorine is added to hydrocarbons in very fast reaction. Chlorine replaces hydrogen atoms one by one. It is called substitution reaction because one type of atom or a group of atoms takes place of another. A number of products are usually formed with higher homologous or alkanes. Many compounds are. We shall study the properties of two compounds, ethanol and ethanoic acid. Ethanol is a liquid at room temperature. For the melting and boiling, ethanol is commonly called alcohol. Is an active ingredient of all alcoholic drinks. In addition, because it's a good solvent, it's also used in medicines such as tincture, iodine, cough syrups, and many tonics. Ethanol is used. It's also soluble in water in proportion. Consumption of small quantities of dilute ethanol causes drunkenness. Even though this practice is common, it is a socially widespread practice. However, intake of even a small quantity of pure ethanol, called absolute alcohol, can be lethal. Also are dangerous. Also, long-term consumption of alcohol leads to many health problems. Reactions with ethanol ethanol. Sodium reaction with sodium alcohol react with sodium to form the evolution of hydrogen with ethanol. The other product is sodium ethoxide. Reaction with unsaturated hydrocarbon eating ethanol gives concentrated sulfuric acid results in the dehydration of ethanol to give ethene CH2 double one CH2 ethene. And the concentrated sulfuric acid can be regarded as a dehydrating agent which removes water from ethanol. Quantities of ethanol, when large quantities of ethanol or alcohol are consumed, it tends to slow the metabolic process. This results in a lack of coordination, mental confusion, drowsiness, lowering the normal inhibitions, and finally stupor. The individual may be feel relaxed without realizing his sense of judgment, sense of timing, and muscular coordination have been seriously impaired. Unlike ethanol, intake of methanol in very small quantities can cause death. Methanol is oxidized to methanol in the liver. Methanol reacts rapidly with the components of cells. It coagulates the protoplasm in much the same way an egg is coagulated by cooking. Methanol also affects the optic nerve, causing blindness. Ethanol is an important industrial solvent. To prevent the misuse of ethanol produced for industrial use, it is made unfit for drinking by adding poisonous substances like methanol to it. Dyes are also added to color the alcohol blue so that it can be identified easily. This is called denatured alcohol. Sugarcane plants are one of the most efficient converters of sunlight into chemical energy. Sugarcane juice can be used to prepare molasses, which is fermented to give alcohol, ethanol. Some countries now use alcohol as an additive in petroleum since it is a cleaner fuel which gives rise to only carbon dioxide and water on burning insufficient air. Property: ethanoic acid is commonly called as ascetic acid, belongs to a group of acids called carboxylic acids. 5 to 8% of acetic acid in water is called vinegar and is used as a preservative. In pickles, the melting point of pure ethanoic acid is 290 Kelvin, hence it often freezes during hot and cold climates. This gives rise to its name glacial acetic acid. The group of organic compounds called carboxylic acids are obviously characterized by their acidic nature. However, unlike mineral acids like HCl, which are completely ionized, carboxylic acids are weak acids. Esterification reaction: esters are most commonly formed by the reaction of an acid and an alcohol. Ethanoic acid reacts with absolute ethanol in the presence of acid catalyst to give an ester. Generally, esters are sweet smelling substances. They are used in making perfumes and as flavoring agents. On treating with sodium hydroxide, which is an alkali, the ester is converted back to alcohol and sodium